Today we're going to be talking about special case answers. So we've been talking about how to solve equations using our different steps that we've learned from the past and justifying those steps. But now there's going to be two special case answers that we could get. One of that would be if there's no solution. That means that no value of the variable makes the equation true. So for example, 2x equals 2x plus 1. There's no way for those two things to be equal to each other because if we have 2x and 2x plus 1, this one would have 1 extra. The other way is if we have infinite solutions, that's where all values of the variable make the equation true. So if we're looking at something like 2x plus 1 equals 2x plus 1, those are the exact same thing on both sides. And when they're the exact same, we know that there is going to be infinite solutions. Alright, so we're going to solve the equation negative 8x plus 14 equals negative 2 times the quantity 4x minus 7. So our first step in solving this, there's nothing to do on the left-hand side, is to distribute that negative 2 in. And in doing that, negative 2 times 4x is negative 8x, and negative 2 times negative 7 is a positive 14. So we could keep going if we wanted, but if we notice here, negative 8x plus 14 equals negative 8x plus 14. Since these are the same on both sides, we have an answer of infinite solutions. Oops. So again, if you get the same thing on both sides, you end up with infinite solutions as your answer. Our next example says solve 6x plus 1 equals 2 times the quantity 3x minus 4. So again, the same type of idea is happening. On the left, nothing is changing. On the right-hand side, 2 times 3x is 6x. 2 times negative 4 is negative 8. Here I'm noticing they aren't the same thing. So can we have infinite solutions as an answer? No, because they've got to be the exact same thing. So now we're going to keep solving. Well, if we're solving here, we would subtract 6x's from both sides. In doing so, our 6x's eliminate on both sides, and we're left with 1 equals negative 8. Is that a true statement at all? Is 1 equal to negative 8? So the answer is no to that. So when we cross it off like that, we're going to say no solution. So when they're the exact same thing, you're going to get infinite solutions. When they're not the same thing, you're going to get no solution. When you get this, 1 equals negative 8, that's no solution. If you end up with x equals something, then obviously it's one solution as we go. So how are we going to know when we're going to get one, no, or infinite solutions? Well, let's start with what I think is the easiest one, which would be to look at infinite. This is going to be the same on both sides. The same on both sides. Well, what do we mean by same? We mean same coefficient and same constant. Okay, let's refresh our memory with those vocabulary words really quick. If I give you 2x minus 3, this 2 there, the number that's in front of the variable, is going to be the coefficient. And this number that's added or subtracted on is going to be our constant. Okay, so both of those things are the same on both sides of the equal sign. That means that we have infinite solutions. No solution, okay, for those to happen on the last example, the x's have to be the same so that they can eliminate. So we have the same coefficient and different constants. So that's where we got 1 equal to negative 8. That's not a true statement, so we have to say no solution. Okay, for one solution, how does that happen? Well, in all of our stuff that we've seen so far, as long as the x's don't cross off with each other, they don't eliminate with each other, we're going to have one solution. So that means that we just need different coefficients. The constants could be the same or not, and that doesn't really matter, but we just know that we need different coefficients for one solution. All right, we're going to take a look at a couple of different charts and the way that these questions could be asked. This seems like a very overwhelming process right now, but as long as you just take your time with it, we're going to be good to go. So this one asks us to fill in the appropriate box for the number of solutions for each equation. So there are 5 equations here, and we need to put a check or an X in 1, 0, or infinite for each of these questions. So ultimately, that doesn't mean we need to solve every single one of these all the way down. We just need to make sure that we're solving it enough to be able to determine if it's same coefficients or different, or same constants or different. So here, if we have 10 minus 8a equals 2 times the quantity negative 8a plus 5, we're going to notice that that 10, oh, can't even see that here. So that 10 minus 8a stays the same. On the right-hand side, when we distribute, we're going to get negative 8a plus 10. So they don't look the same if you just glance at them, but if you look a little closer, 10 minus 8a and negative 8a plus 10, are those the same thing? Yeah, the a's have a coefficient of negative 8 and the constant is 10. So that means that we're going to have the same thing on both sides, infinite solution as our answer. All right, next one down. We have 5m minus 2 times the quantity m plus 2 equals negative times the quantity 2m plus 15. So on the left-hand side, we're going to work on distributing that in. So negative 2 times m is negative 2m, and negative 2 times 2 is negative 4. On the right-hand side, there is a negative 1 there in front of that parentheses, so when we distribute that in, that's going to get negative 2m, and then negative 1 times 15 is a negative 15. Well, if we're looking at these things, we still have some simplifying to do on the left-hand side. That means we would have 3m minus 4 equals negative 2m minus 15. Okay, so now we're comparing coefficients and constants. Well, these coefficients, 3 and negative 2, those are different. The only time when we have different coefficients, that means automatically that we're going to have one solution. We don't care what that one solution is. It doesn't ask us that. It just asks us how many solutions there are. So you don't need to keep solving that at all. All right, we have 9 plus 5n equals 5n minus 1. So there's nothing really to do there except just look at them closer. So first, let's look at the coefficients. The coefficients are the same. Well, if they're the same, that means that we're either in no solution or infinite solutions. So now we got to look at the constants, 9 and negative 1. Are those the same? No, they're not. Since they're not the same, that means that we would end up with no solution. All right, next one down here, we have m plus 3m equals 4. Well, I see like terms here, which means we need to simplify. That would give us 4m equals 4. Here's a coefficient, not a coefficient. So that means they have different coefficients, meaning we would have an answer of just one solution. Now, you could have figured that out over here. This side has m's and this one doesn't have m's at all, which means they obviously are going to have different coefficients, but you can keep going like this as well. All right, next one down here. On the left-hand side, 18x minus 5, nothing to do there. On the right-hand side, 3 times 6x is 18x. And 3 times negative 2 is negative 6. So once we've gotten rid of those parentheses or combined like terms, simplified, we're able to figure out what we got going on here. So the 18x's, those coefficients are the same. And then now we're looking at the constants. So negative 5 and negative 6. Since those are different, we're going to have no solution. Okay, so this is one of those where for each individual question, you must mark something, 1, 0, or infinite solutions. The other way that these questions can be asked is if they ask you to check all the equations that have some sort of answer. So it could be one solution, infinite solutions, or no solutions. This one's asking us infinite solutions, okay? So that means we're going to do that same thing again. Let me scoot this over a bit. We're going to do that same thing again where we're looking to simplify these as much as possible. Here, you're only putting a check if it's infinite solutions. So how do we know if it's infinite solutions again? We need to make sure that both sides have the same coefficient and the same constant. So looking at this first one, a minus 4a equals 2a plus 1 minus 5a. Here, we've got just a's on the left, and then on the right-hand side, we've got a's and a constant. So can these be the same coefficient and same constant for us to have infinite solutions there? No, this one doesn't have any constant with it. Now, you could keep going with that. Combining or simplifying on the left, we would get negative 3a. And on the right-hand side, we would combine and get negative 3a plus 1. So we know that there's not the same. So we don't put anything in that box at all. All right, next one, 2n plus 3 plus 4n equals 5 plus 6n minus 2. There, we're going to simplify. So we have 6n plus 3 equals, there's no like terms to combine with the 6n. 5 minus 2 is a positive 3. Are those two sides the exact same? Yes, they are. So we're going to check in the box there. Okay, next one, 2 times the quantity 3x minus 6 equals the 3 times the quantity 2x minus 4. So when we distribute in, we get 6x minus 12 equals 6x minus 12. Same thing. Yes, they are. Same coefficient, same constant. Put a check in the box. All right, here we go. We've got 7/8 w equals 1/2 w plus 3/4 w. So we got to be able to add those two fractions together. All right, in order to do that, so we'll come down here. If I take 1/2 plus 3/4, because that's what we're going to have to do, we got to get a common denominator between those. So 1/2 is the same thing as 2/4. And 3/4, they already have that common denominator of 4. When we add those things together, we would get 5/4. So is 7/8 w equal to 5/4 w? Because that's what we just got when we combine those. Those coefficients not the same, so we're not putting anything in the box there. All right, next one down here. We're going to distribute this in. All right, so we have, when we take a fraction, so a 3, and we multiply it by 2/5, we have to make sure that this 3 is over 1. It's only going to get distributed to the top, okay? Because when we multiply fractions, we multiply straight across. So that would give us 6/5 x plus. Now this would give us 6/3. Well, 6/3 is just 2. On the right-hand side, 4 times 3/10 is going to give us 6/5. And 4 times 1/2 is going to give us 2. So are those two the same thing on both sides? 6x plus 2 equals 6/5 x plus 2 equals 6/5 x plus 2. Those are the same thing. So it is infinite solutions. So just to recap, you need to make sure you know the different types of solutions. One solution is if they have different coefficients. We don't care about the constants. No solution is where you have the same coefficient, different constants, and infinite is where it is the same on both sides. So same coefficient and same constant.